In this video, we are going to be looking at net ionic equations. And basically, a net ionic equation is an equation that just has chemical species that actually do, I guess you could call it the work within a chemical equation. Some things called spectator ions don't really, they're not directly involved in the reaction overall, and they get crossed out later, as you'll see. Alright, so if we look at this one, we've got HCl, and then we have um, silver nitrate. So the first step that we need to do is to go ahead and finish our double replacement reaction. We know that this is going to be a double replacement reaction because we've got a binary compound here, and basically you've got a silver and a nitrate, which you treat as two separate entities also. So remember, the convention is that positives go first and negatives go second. So silver is going to be positive here, nitrate is going to be negative in this example. So if we are to go ahead and continue this reaction, the hydrogen being positive is going to pick up the negative part of the other chemical. So we're going to have HNO3. Now if we double check our charges, we know that the charge on hydrogen is a +1, and we know the charge on nitrate, which is a polyatomic ion, is -1. So the product HNO3, so this is hydrogen nitrate, or this is actually nitric acid. So we have to, well, to finish out the reaction, we'll go say plus, and then we've got the silver here, which is positive, which is going to combine with the negative part of the other one. So together we're going to have silver Ag chloride. So it's just AgCl. There's nothing on the Cl because the charge on silver is +1 and the charge on chlorine is -1. We know the charge on silver is +1 because even though it's a transition metal, the charge on nitrate here, the NO3, is -1. So to cancel out the -1, that means that silver must be a +1. And if you can remember, silver, even though it's a transition metal, it always takes a +1 charge. Okay, so here are our two products. Now the next thing that we have to do is we have to decide whether these are aqueous or solid, and we look to our solubility rules in order to do that. Well, we know that according to our solubility rules that all things that are nitrates are soluble. So if they're soluble, we're going to go ahead and put an AQ in parentheses behind this to indicate that it's aqueous. So like in the preceding ones, this was aqueous, the HCl and the silver nitrate, that was aqueous also. So if we look at the silver chloride in this example, if you'll look at your solubility rules, all chlorides are soluble except for some exceptions, and silver is actually one of those exceptions to the solubility of chlorides. So in this case, silver chloride is not aqueous, but it is a solid. So we're going to put an S on the end of that to indicate that this does not dissolve. The solubility rules say that this does not dissolve as a chloride. Alright, so now that we've got that, the next thing that we need to do is we need to break apart all of our species of chemicals that actually do separate in water. So that would include HCl, AgNO3, HNO3, because they are aqueous. This one will not because it's solid, it is not soluble. So if we come down here and we'll go ahead and put these into their ionic forms. So HCl, aqueous, is going to break into H plus, and we're going to keep the AQ on that, so that's aqueous, and Cl minus. So we're going to add those. So we'll put a plus there, and then we're going to put an AQ behind that. Whenever you're writing the charges out, you don't really have to worry about numbers per se. We're just more interested in charges at this level. So I'll go ahead and put a 1 here and a 1 here. If you ever see just a plus or a negative by itself, it does mean 1, but I'll put the 1 there to explicitly show that. Okay, so the next thing, we're going to put another plus, and we've got silver. So silver, we'll go ahead and put Ag, and we know the charge on silver is +1, as we've already stated earlier, so we'll go ahead and put a plus or a +1 on the silver, and it is in an aqueous solution, so we'll put the AQ behind that. And then the next thing we have is this nitrate, so we're going to put plus NO3, and the charge on nitrate is -1, and that's going to be aqueous also. Okay, so now we're at our arrow, so I'm going to go ahead and draw our arrow here. So the next thing that I'm going to draw, because I'm not going to have enough space on the right, I'm going to kind of write towards the bottom, but just keep in mind that the stuff that I'm writing here really should be on to the right of the arrow. So we've got the HNO3, which is aqueous, so I'm going to put my H plus, and I'm going to put an AQ behind that. I'll go ahead and put a 1 to be consistent with that. And then NO3, so I'm going to say plus NO3, -1, and that's aqueous also, so I'm going to put an AQ behind that. Okay, so now the next thing I have is plus, but I have AgCl. Now we've said that this was insoluble, so that's what the S stands for. It stands for it's solid, which means it will not go into solution. So we don't have to worry about breaking the AgCl down like we've done the previous examples. So we'll just go ahead and simply write AgCl with the solid on it. Okay, so at this particular point in the game, the hard part's kind of done. Now once you've got this, your ionic equation kind of broken out, we can go ahead and start canceling some things that show up on the left and show up on the right. So let's just go ahead and start with the first one. So we've got H plus. I have a H plus here, and if I look to the right hand side of the equation, I've got an H plus here. So I can go ahead and mark out this H plus, and I can mark out the H plus on the left, because they essentially cancel one another out. These are called spectator ions, which means they're in the equation, but they don't really, they're not really involved in the reaction. Okay, they basically just watch, if you will. That's what spectator means. So now, if we move to the chlorine, we've got a Cl -1 on the left. If I look over onto the right-hand side, I see CO here, but it's not Cl -1. So this is not the same thing as this. So I move on to the next species. We've got Ag plus 1. So Ag plus 1, I don't see a Ag plus 1 on the right-hand side of the equation, so I move to the next species. Here I see NO3 -1 on the left, and if I look, NO3 -1 is also on the right, so once again I can cross this out and I can cross this out. And once again, these two NO3s are spectator ions because you find them on the left and the right, and they essentially they do nothing for the overall net equation. Okay, so at this point, what we're going to do is we've crossed out some stuff. We've kind of started to make it a little more simple. Now we're going to write down what we have left. So I'm going to scroll down just a little bit so we can have a little more room here. Okay, so I'm going to switch colors, so we'll try the green. So the first thing we have is a Cl. I typically like to write the positive ones first, so I'm just going to write silver first. So I'm going to say Ag, and I'm going to keep my positive 1, and it's aqueous. I'm going to keep my AQ just like this. Okay, so the next thing that I've not crossed out is my chlorine, so I'm going to say plus chlorine -1, and the AQ still stays with the chlorine. So now, that's everything on the left-hand side of the equation. Now I can draw my arrow. And the only thing left on my right-hand side of the equation is the AgCl. So I'm going to write that AgCls. Okay, so now I want to double check to make sure that everything is balanced. So if I look, I have 1 silver on the right, I have 1 silver on the left, I have 1 chlorine on the left, I have 1 chlorine on the right. So this is a balanced net ionic equation. So if someone were to ask, what is the balanced net ionic equation to this particular problem, this is your answer. So this is the net ionic equation for this. One other thing that we can look at, because AgCl is a solid and it is not soluble, AgCl is what's referred to as a precipitate. Precipitate. And it just means that it comes out of the solution. These two guys, the silver and the chlorine, are actually dissolved in water, which is denoted by the AQ, but when they get mixed together, they form a solid which will come out of solution, and the solid AgCOS we call the precipitate.